All right, let's take a look at some sampling distribution problems. So our first problem, we have a population has a mean of 100 and a standard deviation of 27. Assuming, okay, this is that our samples population, our sample size divided by our population is less than or equal to 0.05, the probability that the sample mean of a sample of 81 elements is going to be between 91 and 97 is. So again, the difference here is it's telling you that there's a sample of a certain number of elements, so that's going to key you in that this is a sampling distribution, which is a different type of problem. So let's see here, we'll go pink. Okay, so what we need, the information we need for this problem is we need the sample size. So the sample size N is 81. We need the mean, okay, so we say that the population mean mu is going to be equal to the population or the sample mean, so mu of x bar here. So population mean is equal to the sample mean, which is 100. And then we have the population standard deviation is given to us as 27. And then what we need is the sample standard deviation. So this is your new part here. So your sample standard deviation is the population standard deviation over the square root of your sample size. Okay, so let's go ahead and find that value here. So our population standard deviation is 27, and our sample size is 81. So 27 over the square root of 81 is going to give us, let's see here, 27 divided by second square root of 81, 3. So our standard deviation is now 3 instead of 27. So it's going to change things a bit. All right, then what we need to do here to find our probability. So what we're asking is the probability between, okay, that x is between 91 and 97. Okay, we're going to find the z-score for 91 and 97, and that formula is the same formula, you just have to use the different standard deviation. So it's x bar minus our mean of x bar, or just our mean, over the standard deviation of x bar. So the standard deviation is just different here, okay? Once you find the standard deviation of x bar, that's the value you're going to be using. So for 91, we're going to go 91 minus 100 over 3. And then we're going to get that z value, so 91 minus 100 divided by 3 gives us -3. Let's go ahead and mark it on our standard normal curve here, -3, right there. And then what is our next one? We've got 97 minus 100 over 3. I think that's going to be a -1. And we get -1. Okay, so here's 0, here's -1. So here's what I'm looking at. Okay, I want this value here. Okay, you want that area there. So we're going to go in our calculator, normal CDF. Our lower limit is -3. Our upper limit is -1. So we're going to go in here. Second vars, normal CDF, -3, comma, -1. Whoop, hold on. There we go, -1. And then, of course, our mean here, since we did normalize these or standardize these scores, our mean is 0 and our standard deviation is 1. So we get 0.157. All right, and let's see here. And it looks like actually we're going 4 decimal places on this case. So 1.1573. Okay, so then the next problem we have is similar. We have a population has a normal distribution, there it is, with a mean of 48 and a standard deviation of 9. Okay, we're assuming that our parameters are good, population or sample size is big enough. Probability that sample mean for a sample of 25 is more than 51.15. Okay, so our sample size, 25. Our mean, which is equal to our mean of x bar, is 48. Population standard deviation is 9. So our sample standard deviation is going to be population standard deviation over the square root of our sample. So let's see, 9 over the square root of 25. So 9 over 5. I think that is 1.4. 1.8. Okay, so we get that value there. Let me, something that might be a little easier to see on the graph here. Okay, so our standard deviation of our sample is 1.8, and then we want the probability that x is greater than 51.15. Okay, so let's standardize this score. So we're going to go z equals 51.15 minus our mean of 48 over our new standard deviation, 1.8. So we're going to get 1.75 for our z-score. All right, so if this is 0 and this is 1, 1.75 is probably about right here. Okay, and we are doing greater than that, so we're going to the right. Okay, so our lower limit is going to be 1.75. And our upper limit, we don't have an upper limit, so we're going to put that in as 99. Okay, so second bars, normal CDF, 1.75, 99. And that gives us 0.04, which is this area here. Oh, it went away. 0.0401. All right.